Welcome to Geometry Pre-AP today. Today we're going to work on word problems and going over some of the processes and the wording to help you work with word problems a little bit better in trigonometry. Always remember to reset your calculator, second plus 712. So as I bring my calculator up, remember to turn it on. And so second plus 712. Resets that calculator, and then since we're doing trig, we got to remember to go back into our mode. And trig is angles are measured in degrees, so we got to set our calculator to degrees so that our calculator will always work correctly when we're doing trig. Alright, so some terminology when we start to teach trig is we have to learn what the angle of elevation is and how to draw those figures. In the word problems, you'll sometimes see angle of elevation used a lot. An angle of elevation is an angle formed by a horizontal line and the line of sight to an object above the level of the horizontal. So it's when we're looking up at something. So when we have an angle of elevation, we have our ground and we have ourselves standing on the ground. And this is our horizontal line of sight, and then we look up at something, say some object. Here's our little balloon, and we create this angle of elevation right here. This is our right angle, and so since we have a right angle, this becomes our trig. So if we have the angle of elevation, this is our opposite, this is our adjacent, and of course this is our hypotenuse. One of the benefits is that you have to read the word problems very carefully, but if you see the word angle of elevation in the problem, always draw a picture with this kind of triangle. Sometimes they won't tell us angle of elevation, and you'll just have to draw the picture with the way they describe it with the words. In that case, you read the details very carefully. Okay, the other type we have is an angle of depression. An angle of depression is an angle formed by a horizontal line in the line of sight to an object below the level of the horizontal. So it's kind of like when I'm up here on this cliff and I've got something water out here or something like that. And so I'm up here on this cliff and I'm looking straight out and I see something like, let's say, a little boat out here. And so I look down at that boat, and so there is my triangle. This is my depression angle. This is my right angle. Sometimes I'll be given this height here, and it's like a big rectangle. So if this height's here, it can also be the height here. This distance to the boat is here, which could be the same here. And we don't tend to use this hypotenuse here, so we don't really use this value a lot because this doesn't really matter as much. We want to know how far the boat is away from land, not a direct angle in this case, or a direct line to the boat. Sometimes we can ask for that. I would say read the problem carefully and you'll know. So again, we'll go through this here. Here's a little rectangle of the situation. This is the elevation angle. This is the depression angle. We know this is the height. This is the distance to an object. So this is the distance to an object. And this is direct distance to an object. You have to read carefully to see if this number is needed or given to you. One of the things we notice about this whole entire figure, though, is it's a big rectangle, which means these sides are parallel, but also means that these two angles are actually congruent. So the angle of depression and angle of elevation are actually the same angle. I would suggest you draw the separate triangles for each one and work with it that way rather than trying to draw the big rectangle every time. Alright, so here's our first word problem. Okay, we're going to draw a picture, find the answer. Our sides need to be to the nearest hundredth and our angles to the nearest degree. It all depends on the worksheet of how you're going to work that. So first we have a surveyor standing 100 meters from a bridge. So I guess we need a little picture here. So here's my ground. Here's my surveyor. And they're 100 meters from a bridge, so I guess I need a bridge here. Want to draw this as best I can. I know my drawing's not great, but it's a picture. So they're 100 meters away from the bridge. All right, put your units in there. She determines that the angle of elevation, so she's looking up to the top of the bridge. This is going to be my right angle. It's 35 degrees. And she says, find the height of the bridge. This is our unknown here. But it says the surveyor is 3 meters tall, so this is 3 meters here, so this is 3 meters. So I need to find this unknown value here so I can add the 3 meters at the end. So since I have my triangle, this is my angle. So this is my opposite, this is my adjacent. We go back and see our SOHCAHTOA. Since I have my trig stuff there, opposite and adjacent is these two. So I'm going to do the tangent of my angle, which is 35 degrees, equals the opposite, which is x, over the adjacent, which is 100. Make our proportion, cross multiply, so x is equal to 100 times the tangent of 35 degrees. Now you'll notice I haven't brought that 3 into the problem. It's not needed yet. First we need to find out what that distance is there first. And when I do all this work here, I get 70.021. That is our x value, but I want the height. So the height is the x plus 3. So I've got the 70.021 plus the 3. So I get 73.021 meters. So always read these problems carefully. Go back and check. Make sure you're answering the question and putting the units. Moving on to our next page. We're going to do another one here. We have a lighthouse and we have an angle of depression problem. So let's go ahead and put our lighthouse in our problem here. Here's our lighthouse. And it says the angle of depression to a buoy. Well, I guess we got some water here, so let's put some water into this problem. Tend to have water around lighthouse. All right, and then we have our buoy out here. And so remember that a depression triangle goes from the horizontal and you're looking down at an object. And it says that the buoy has an angle of depression of 25 degrees and the top of our lighthouse is 150 feet. Now, if that lighthouse is 150 feet, we can take that same value and put it right here at 150 feet also. It says, find the horizontal distance from the buoy to the lighthouse. So we're looking at from here to here, so that's x. So I put that in here, and then I look at my trig. I have opposite and I have adjacent, so that is the tangent of 25 degrees equals opposite, which is 150, over adjacent, which is x. When I work this problem, create a proportion, x is going to equal 150 divided by the tangent of 25 degrees. So I end up here with 321.676 feet. Okay. Now, when you're dealing with jets, that's a special situation. A lot of times they give you the information. It says that the jet's going to achieve a height, an altitude of 12.6 miles. What is the angle of elevation? It says the jet travels 56 miles. When we're talking about traveling, we're always talking about ground distance. So the 56 goes here, not the diagonal line. People will put that in the wrong place and ask for the angle of elevation. So I label my information here. This is my opposite and my adjacent. So the tangent of x degrees equals opposite, which is 12.6, over adjacent, which is 56. I go into my calculator, I put those values into my calculator, and I end up getting x is equal to 13 degrees. All right. So I want you to do this Eiffel Tower problem. You can pause the video, do this on a separate sheet of paper, and also do this problem about a wooden beam. And those will be the two problems that you turn in to show that you have viewed the video and done the work. If you have any questions, write them down on that piece of paper when you're doing these two problems, and I'll be glad to go over those with you when you get to class. Thanks for watching the video.